Okay, so today we're going to look at one of your core practicals, which is investigating force, mass and acceleration. So what we're looking at today is Newton's second law, and here's the relationship on the board here. So if you look, we've got force equals the mass multiplied by the acceleration. I'm just going to go over the basic principles of this. The bigger the mass, the smaller the acceleration. The bigger the force, the greater the acceleration. So during your practical, you'll be asked to write a prediction on page 82, which talks about the relationship between acceleration and mass. So you would predict, because of Newton's second law, that the bigger the mass, the smaller the acceleration. So what you're going to be eventually plotting in today's practical is this graph. So acceleration on the y-axis and total mass of the trolley and the masses put together on the x-axis, and that will be summarised in your practical book on the grid there. What I'm going to do is spend the first part of this practical going over the setup and what it is you need to do and why we're doing each step, and then we're going to look into collecting results on the data logger on the computer. Right, so your teacher will go over the setup with this with you. You will not get to do this because we haven't got enough light gates. So these are called light gates, and this is called a data logger. All this is doing is communicating between the light gates and the computer. So eventually we're going to get some results on this computer here. I'm just going to go over the basic setup with you now. So for A, it says prop one end of the ramp and place a trolley on it. Adjust the slope of the ramp until the trolley just starts to move on its own. Gravity pulling the trolley down the slope is now slightly greater than the friction in the trolley's wheels. So essentially what I've done is I've got a ramp, I've got a clamp stand attached to the ramp with a clamp on it. I've angled it ever so slightly so that the cart will naturally move due to gravity. On part B, it says, stick a piece of card on the top of the trolley using a sticky putty. Leave enough space to stack some masses on top of the trolley and measure the length of the card and write it down. This will already been done for you. So we've got our trolley with our piece of card on and some sticky putty. Now the length of the card is 150 millimeters, so that will be done for you. The reason why we're using the card is because the light gates need to use this piece of card to detect the trolley. That's why we're using the card. In C, it says find the mass of the trolley and write it down. Now you should be familiar with using a balance. So this is your balance. All you're going to do, before you've put the trolley on here and before you attach this string onto it, which I'll come onto in a moment, you're going to measure the mass of the trolley, because eventually you'll be filling out this results table which requires you to know the mass of the trolley. Once you've done that, you can move on to part D. It says fasten the pulley at the bottom end of the ramp and arrange the string of masses as shown below. So you are given a diagram of how to set up this practical, and I will just show you that setup now. So I've got a string attached to my cart. The practical book calls it a trolley. The string is going through both light gates here to this pulley, and the pulley has got a small mass attached to it. That is so that the mass can ever so slightly provide a small amount of force, an amount of force big enough just to get the trolley moving. All right? Once you've got that bit, it says in part E, set up two light gates, one near the top of the ramp and one near the bottom. To calculate the acceleration, you need to know the initial velocity, which is what this light gate will be calculating, and you need to know the final velocity, which is what that light gate will be calculating. Because eventually in your table, you are going to be putting those calculations into this equation. A equals V minus U over T, where A is the acceleration, V is the final velocity, U is the initial velocity, and T is the time. You are given this equation in your practical book underneath your table. Once you've done that, you can move on to F. Put a mass on the end of the string. You will keep this the same mass for all your tests. So I've just talked about that. That is this here, just a mass there, and you're going to keep that the same. You don't need to mess with that once it's set up. What you're going to do is you're going to release the trolley from the top. Now, this is where it gets just a little bit tricky, and I'm going to go over with you how to set this up. So all I've done I've got a wheel at the back of the trolley, and that's just stopping the cart from falling. All right? So my trolley is fixed at the top at the moment because I've got a wheel at the top which is stopping the trolley from falling down. And in a moment I'm going to release that trolley. Now it's all set up ready to go. On my computer I'm going to be generating some results, and this computer will give you the results that you need to write down in your table, and I'm going to go through with you with this now step by step. So in your table, masses added to the trolley in kilograms. To start with, you can set that as 0. So your first result there will be 0 because you're not adding any masses to the trolley. So the total mass of the trolley and the masses in kilograms, that will just be the mass of your cart which you measured at the start. All right? Once you've done that and this is ready to go, you can click Start on the computer. I don't need to touch the computer now for the rest of this experiment. It will just continue recording results. So what I'm going to do now is I'm going to release the trolley from the top of the ramp. As soon as you take the trolley from the end, it will start to move. So make sure you move away as quickly as you can. That should be your first result. Now if you look at the computer, it tells you the speed, which is your average speed. It tells you the speed at A, which is the first light gate, which is that one there. It tells you the speed at B, which is the second light gate. And it tells you the time that it's taken to travel between both light gates. All right? So, in your tables, where it says U first, you're going to write in the red number there, 0.32. Where it says V second, you are going to write in 0.79. That is your final velocity. And where it says time between the measurements, that will be your one in green, 1.28. As you can see, it generates a graph for you on the system. All I'm going to do now is I'm going to reset my trolley, and I'm not going to pass the card in between the light gates, otherwise it will start to detect movement and it will give me false readings. So I'm going to pull the piece of card around the light gates and I'm going to set it back up so that my piece of card is in line with both light gates. If you're unsure, just stand above it and make sure you've got it accurately. What you're going to do then is you're going to add masses. Now this is for you to choose. Ideally, you need to go up in regular intervals. So, just to show you an example, I'm going to add 3 of these. So that is 3 grams, all right? And I'm just going to put those masses on here like that, all right? What I will write in there now, mass added to the trolley. I will write 3 grams, and I will need to convert that to kilograms. I do that by dividing it by 1,000. And then I'm going to add together my mass of my trolley and the mass of the masses I've just added on. And then I do the same thing again. I'm just going to release my trolley, and my data logger gets some more readings, 3 more readings. So my speed at A, which is your first column in your table, so I'll write down the red number. Your speed at V, which I'll write down the blue number, and your time, which I'll write down the green number there. And you'll do that one more time by simply adding more masses to your trolley. So if I bring the trolley back to the top, I'm going to add more masses, make sure it's in line. Now I'm not going to make an accurate measurement, I'm just going to add a couple more, and you're going to repeat the experiment again. The principle is exactly the same. You record the amount of mass that you've added onto your trolley. You add that to your mass of your trolley to get the total mass, and then you can get 3 more readings by releasing the trolley. And on the computer, it generates a speed at A, which is your initial velocity in your table, your U value. It tells you your speed at B, which is your V value, your final velocity, and it gives you your total time between the 2 light gates, which you'll write down in that final column there. The last thing that you will need to do is you'll need to calculate your acceleration. This is very simple, and you do it by using this equation, A equals V minus U over T. So you are going to do the number here for V, take away the number written down for U, and you're going to divide that by the total time it took between the light gates, and that will give you your acceleration in meters per second squared. Once you've calculated your acceleration for each mass on the trolley, you're going to plot a graph, as I've already explained, and you will do that for the acceleration against the total mass of the trolley and the masses. So just be careful, you're not looking at the first column in your table, you are looking at the second one, the total mass of the trolley and the masses added together. So I'll just reiterate, you need to add together the mass of the trolley and the masses for that. And then you'll plot your graph. Your graph, because it is a negative correlation, as you increase the mass, the acceleration decreases, your graph should look something like this. And then you will draw a line of best fit on your graph, which needs to go through the majority of the points. So just make sure that when you're drawing your graph, you put the units in grams for your mass, and for your acceleration, the units is meters per second squared. Everything in here is written to help you. There's even a little diagram there to show you which way around your axes need to be. Once you've done that, you can move on to these questions about considering your results and evaluating your results. And then you finish the practical.